Yeah, hello. This is the first session of our transdisciplinary conversations in the master program Design and Creative Leadership. So I'm here today with our very inspiring guests, Heather Barnett. She's a pioneer in the field of more than human design. And I think she will tell us a bit more about her fascinating projects. And our second guest is Steffen Finck, who's a researcher at FHV. And you're an expert in evolutionary algorithmic studies, we could call it. Franziska Gold, she's a student in the first course of Design and Creative Leadership. Yeah, what made you delve into this field of biological organisms and how did you find this research field?
I think it found me. It's not something that I made a decision about. It's just a kind of direction I took. And I think I've always been fascinated by complexity of biological systems. So as a child, I would spend time watching ant colonies and trying to understand what was going on and how they seemed so purposeful and busy. So I wanted to understand what was happening within that system, and I was interested in watching operations and the complexity of the human body and what lies underneath. And the direction I went in terms of studying was the photographic arts, my practice has evolved over time to combine living systems and imaging technologies. And the imaging technologies allow us kind of access to these hidden worlds. So if something's beyond scale or is operating at a different time scale to how we operate, imaging technologies can help kind of mediate between species. So I've worked with a range of living systems, from the skin bacteria that grows on the surface of our own bodies, to working with plant systems and botanical processes, working with the tropisms of kind of geotropisms of roots seeking gravity and photo responding to light. And then in more recent years, I've been working with superorganisms. So where there's many agents in a system and a lot of complexity emerges from the kind of multiple interactions that happen within that. So looking at ant colonies and slime mould cells, which is a kind of long-term co-creator of mine.
Mm-hmm. And what does intelligence mean for you?
I think with thinking specifically about superorganisms, it's a kind of an embodied and distributed information kind of system. And the slime mould particularly, so the slime mould is a single-celled organism. It doesn't have any sensory organs or any neurons. It's just a bunch of cells operating together as a kind of mass supercell. But it's chemically sensing its environment all the time. And it's adapting and a kind of dynamic flow of information channels, constantly assessing its environment. An ant colony behaves similarly, but you've got your individual organisms that are kind of entire in themselves, but the intelligence of the colony is from that kind of holistic. The individual ant isn't very smart, but the intelligence arises from multiple interactions through pheromone trails and other communication mechanisms within the colony. So the intelligence, I think, is two things. It's about the information flow in the system that is dynamic and kind of has feedback loops, so there's a constant kind of flow back and forth. And it's also embodied, and it's in relation to the environment. So these organisms are constantly in dialogue with their environment. So it's not just kind of their intelligence comes from this relationship.
Yeah, so, and to you, Steffen, you work with artificial intelligence and evolutionary algorithms. So our question will be, what drew you into this field, and what do you find most fascinating about machine-based learning?
So how I entered the field is a little bit more straightforward. So I did the engineering study when I was younger. And in engineering, you have a lot of different topics you can choose, and at some point you have to specialize on something. And I was always more inclined in the mathematical parts instead of building things. So, and then I think it was in a lecture, I stumbled across these genetic algorithms and neural networks, and I found it really fascinating how you can use mathematics, computer code, not necessarily machines, it's more like software and mathematics to optimize something that evolves by itself, right? So you don't have fixed rules, you don't give any route how to find the solution, but the algorithm itself manages to find the solution on its own with those simple rules it has. And I found it really fascinating. I liked it, and at some point I decided, okay, I just not want to study it. I also want to participate in the field, and then I did a PhD, and a lot of my research work is in this field. And I think the second part was of the question, is also what's intelligence in this regard?
So the same question, what's intelligence for you in that regard?
Yes. So I also teach a course on artificial intelligence here, and there's also one of the first points is to say, so intelligence is really not well defined, because intelligence itself is very complex. I think there are 15 different definitions or 15 different types of intelligence. Maybe it's 16, maybe it's 13. It's around this number somewhere. And so this speaking about intelligence is really difficult, because you usually speak about something that's not really well defined. But for me, intelligence, or in case of artificial intelligence, evolutionary algorithms, I think is also this, you have a complex problem and the machine, the system is able to find a solution to this problem. Or not always sure if it's a solution, but it's at least a way to navigate through these complex systems without me telling how to do it, right? I just give them simple properties and they can use these properties. They maybe are able to evolve these properties to get new actions and then be able to navigate the complex systems. And this is probably better phrased with learning. And then we have to talk about what's the difference between intelligence and learning. I don't really know, to be honest. But I think learning is maybe, for me, the better word. But this is also the interesting part. And of course, learning is sometimes coupled with intelligence, right? So if you never learn, if you don't evolve, I think there's at least one of those 15 different types of intelligence is not there. And on the other hand, machines and software, they don't have certain types of intelligence, right? They don't have any emotional intelligence or social intelligence because they don't need it, at least for the moment.
Yeah, that brings me to the next interesting question. So what's the difference between human intelligence and machine learning, or the type of intelligence that, for example, superorganisms have? Is there a difference, or is it just different types of analogies we use, or metaphors we use to understand how artificial intelligence or machine learning works?
Me? Yes, I think it's the latter. It's more an analogy because the machines, software, whatsoever, the technical part, they don't really know that they exist, right? They don't have a conscience, right? They have the abilities, or we give them the abilities that they have similar properties like the human eye or the human language, but we have to give it to them. They don't have it by default, and we have to give them the tools that they can simulate this. And I think this is a very important part. It's a simulation of the behavior. At the moment, the simulation is that good that we can't really distinguish between human intelligence and this machine intelligence. I mean, the best examples are this generative AI stuff, right? So if you speak to a chatbot or something like that, at the moment, this could be a conversation you have with somebody else. This could even be a more inspiring conversation than you have with an actual human. But I think also, besides the points I mentioned before, that there are certain parts or certain levels of intelligence not existent and also not required. For machines, intelligence is mostly something associated with logic, right? So it's a pure logic. So I want to achieve a certain goal, and then I do everything to achieve this goal. Or, I mean, today machines, they can achieve several goals at the same time. But it's always some kind of goal orientation. For humans, I'm not sure that this is always that goal-driven, right? For intelligence, we could also say, well, I don't want to study today, but I want to go out today. And I'm not sure what kind of intelligence this is, but machines don't have to go out. Yeah, that would be my difference. So this, it's a different environment in which they act, and the intelligence of the machine is much more mathematical-based, logic-based, and they don't have, at the moment, they will also not have emotions, but maybe they can simulate emotions, but mostly it's a simulation of what we think is intelligence, what we feel is intelligence.
Mm-hmm. So thinking about biological organisms, when we are one of them, which often we forget, then yeah, I guess it's about the context of the environment, and we are kind of multisensory, and we're engaging with our environment in different ways and trying to and understanding, navigate it. Even evolution doesn't have a purpose in itself, but each organism has a kind of intention and motivation to survive. And I think humans have a tendency, or have had a tendency, to reduce non-human intelligence as a mechanistic thing, that the organism is just trying to survive, but it doesn't really understand itself, and it doesn't understand kind of its place in the world. And I think, on one hand, we're never going to know how another organism operates, because we will only ever be the human looking at this other form of life. But I think in recent decades, our understanding of non-neuronal intelligence has expanded hugely into kind of slime mould research, plant intelligence, and the kind of dynamic mechanisms and strategies that plants have to not just survive in their world, but to really coexist with other species. So from kind of emitting certain chemicals to attract predators or to defend themselves, or and then the mycelium network that runs under the forest floor that is distributing nutrients and information, connecting the entire forest above ground. So I think in those biological terms, we've been kind of questioning, okay, well, maybe our definitions are too neuronally based. And I think this also is in parallel with the developments in artificial intelligence and machine learning, kind of how do we navigate these other forms of intelligence? And the algorithms that we're mentioning, there's a lot of algorithms that are drawn from biological systems. So the slime mould is attributed with solving the travelling snails problem. Ant colonies, algorithms are used for resource distribution. So am I allowed to ask questions? Because I was going to just ask, I was thinking I was going to go from one, but that might not be how you want to do this. But because I'm not working in computer science. I'm working very much with the organisms. So I wanted to ask what you think of those. How practically useful are those algorithms that have been drawn from kind of biological systems?
They are useful. Several algorithms exist for many decades. They have found their niche application, maybe a traveling salesman problem, maybe some kind of optimization problems. And they are still also used in those generative AI applications. Maybe not if you speak from a website, not from the front end, but in the back end. So most people don't know about this stuff. Also, the neural network itself, it's an analogy for the human brain. It's unclear how good this analogy is. whether this classical neural network actually represents what's going on in the brain, or whether it's a really abstract and really idealistic scenario. But if you go deeper into the technical details, for example, for the training of ChatGPT, there's something called reinforcement learning with human feedback. So that's how they train ChatGPT, or it's part of the training of ChatGPT. And for example, for those training of this reinforcement learning algorithms, you can use evolution strategies. It's also a nature-inspired algorithm that draws inspiration from evolution. And it has shown that this is really competitive. It's not competitive always. It depends on the context. It then depends on the problem, which usually depends on how large is the problem. So how many parameters do you have? How many different scenarios you have to consider? And once you get to a very large number, you have to use this kind of algorithms because they provide at some point the only computable route to do this. Because you can't then use classical method like backpropagation or something like that, because you would have to deal with huge matrices, a lot of computational overhead, and you could achieve this with strategies drawn from nature.
And what types of problems could you solve? Could you give us an example so we can imagine?
So I think we go a little bit off, but for these evolutionary algorithms, it's not that they are approach for a specific kind of a problem. So actually the attractiveness is that you could solve anything with it, because they don't need much. You only need something that gives the algorithm and feedback. This is a good solution, this is a bad solution, this is a better solution as the other solution. And then the algorithm, what they do, they use this information to find, over time, better solutions. Yeah? And then the only question is whether you can state your problem in some kind of we call that usually a fitness function that gives you a feedback. This is good, this is bad, some way. And then you could apply that to traveling salesman problem. You can try to find the best neural network. You can try to optimize some structure so that is has not the right amount of ratio between weight and structural fitness. I'm not sure what the correct English word for this is. Yeah, but so you find that across all disciplines. Yeah, but usually it makes sense if you have a complex problem that's tough to describe in an analytical way, where you only have a function where you can solve this, or several functions, and where other methods, for some reasons, cannot provide a good solution.
Okay, so maybe switching a bit over to the designing aspect. So Heather, how, from the designing perspective, how might principles from natures like collective behavior or decentralized intelligence or emergent structures help with creative processes or designing processes?
Okay.
It's a very different direction.
Not really. Or also with solving complex problems, because most of the time in design processes we nowadays try to solve complex problems or address challenges
or
in a way.
Wicked problems.
No, so I'm an artist. So I'm working with living systems and kind of bringing questions to that inquiry with the living systems. I'm not in the business of solving problems, but I think I am in the business of raising questions and inviting other people into the kind of the world of the other organisms. So I kind of see my role as mediation, and imaging technologies help me in that mediation. So I'm inviting humans in to encounter an organism they may not know about or have encountered in other realms. So the slime mould is not a well-known organism. They exist in the natural world across temperate woodlands on every continent. There are 1,000 species of them, so they are ubiquitous on the planet, but they are small and they live in the undergrowth and we don't know much about them. But in laboratories and studios, they're used as a model organism, and many people are asking questions of this organism because it's incredibly simple, yet it can compute. So it's considered to be a biological computer. It can optimize networks to a really high degree. So it's been used to as a kind of comparative model for lots of existing transport networks, trade networks, kind of route planning, and kind of solves mazes, etc. So there's a lot of computer scientists very interested in the organism and seeing it as a biological computer. But equally, there are creative researchers from architecture, from urban design, from other forms of kind of product design. So a few examples from the design world. Urban planners and kind of urban designers, I think, looking at it as resource distribution because of its networking properties. I know there's airplane in terms of product and material design, thinking about the sort of optimized network that you have the maximum strength for the minimal weight of material. So in airplane panels has been used. And yes, kind of looking at any kind of network formation, the slime mould can be a kind of useful comparative model. Obviously, the slime mould is going to be working out and computing in its own subjective reality. It's not there to solve our problems. So there's a limit to how practically useful it is as a model, because it has no awareness of the questions we're asking. But I think it's a vehicle through which we can think with and look at a different kind of network formation. I think I'm interested in it as it's a kind of a relational thing. So there's an ecological and environmental kind of subtext, I think, to a lot of my work, which is about hierarchy of species and human exceptionalism, and trying to challenge that a little bit. So we prioritize. We think we are the superior species. We are one out of 8.7 million estimated species on this planet. We are far younger than slime mould. They've been around for billions of years. We've been around for just a few 100,000, I think. Kind of blip. Humans are a tiny blip on the sort of geological life timeline. And so I think, part of what I'm trying to do is open up kind of worlds for other people and say, look at this. All artists do this. They kind of notice things and they translate them and they mediate them for other people to kind of join those worlds. So there's not a direct problem-solving thing, but it's an awareness raising and perceptual shift that I want to try and create. Creating a space that people can take time to ponder and appreciate the natural world and the complexity and intelligence of it.
Yeah, we also, in our studies, we talk a lot about critical post-humanism. So in a way, it would be, from a post-humanistic world, view, it would be collaborating with the slime mold, as a team. It's also taking part in the problem-solving or designing process.
If I ever use the word collaboration, which I have done, I put it very heavily in inverted commas. Because I am collaborating with the slime mould, but the slime mould is not collaborating with me. The slime mould is not choosing to work with this curious human. So I think probably a more accurate term is a form of benevolent slavery. That I'm nice to it and I care for it and I have a kind of ethics of working with it. But actually, who's slave to who is debatable, because I have to kind of nurture it and care for it, and so sometimes I feel that I'm more the slave to it than the other way around. But No, I'm kind of asking it to perform for me. I create environments for it to navigate. I bring kind of questions to that, the creation of that environment. So I'm creating the conditions for hopefully something interesting to occur. I introduce the slime mould. I photograph it with time-lapse photography to amplify those behaviours because it grows quite slowly, 1 centimetre an hour. But I can't control the outcome. So I'm just creating the conditions, hoping it does something interesting. But I am kind of asking for it to perform for the camera and for me and intervening on the way. So I use the term co-creation because it is creating. It may not be intentionally creating in a way a human artist may be, but I'm not controlling the outcome. It is surprising me what it does. I can predict its behaviours, but I can't control the outcomes. So it is a negotiation and a kind of nudging and an intervening along the way.
Thank you.
Can we ask the same question about collaboration with an AI? Can you collaborate with an AI?
No.
Or would it be co-creation? How would you define the relationship
or benevolent slavery?
Yeah. Who's slave to who?
Yes, I think you can create with an AI together. You can do that since, I think, in a meaningful way, just since a couple of years, maybe 2 years, maybe just 1 year, because the systems to do that were not existent before. But today, I mean, you can sit down with any kind of generative AI and use natural language to say, please do this for me, and what are options or alternatives for this? And so you can go in a creational process with the AI. Who's the slave to whom? I don't know. I don't want to answer that. Well, I can't answer that, right? Because there is different viewpoints. Of course, I give the instructions that it should something be created. I would like to have some proposals, some ideas the AI should create for me. At the other end, I have to always still judge, are these good ideas? Does that make sense? Or is it some errors or failures I shouldn't use? But of course, if you think about longer times, if we start to outsource all of these ideas to the AI, at some point, we don't have this creativity in us anymore, because we don't need it anymore, right? And that would be a bad thing, of course. But if we outsource this to the machines at some point, well, we need the machines for everything. But this is probably not the future all of us want to live in.
I'm not sure we would ever get to that point where we don't need human creativity, because the lack of emotion, you're talking about the different intelligences, and the AI will never have an embodied sensory, emotional, social intelligence.
I would be careful with the word never.
Ah, okay. So how would we get from here to there then? How would...
I mean,
Sophia from Hansen Electronics is more like the uncanny
if you think about, okay, we go away from like the server applications and the computer, we put that everything in a robot, right? So
then it's embodied?
Then it's embodied, yes. The robot can have a lot of sensory input. So it feels is the wrong word, but it measures the temperature, the pressure, the light, the day. It could measure how many other robots are around it, and then it can start to feel anxious or it can start to feel good. And so I would be really careful about this never, because I mean, there is this, I think it's since the 70s, there is this questions put forward to researchers, when will we have this artificial general intelligence that then surpasses the human? And since the 70s, the answer is always the same, in the next 25 years. So it's still the answer right now, but we are probably closer to those 25 years than we were in the 70s. But even there, the community, I think, is very divided. Some people say it's right there, and others say, well, we will go there, we will never achieve this. And nobody knows at the moment. Yeah.
Can I ask a follow-on question?
Of course.
Because you said the robot feels anxious or the robot feels good. How is it feeling that? And is that something that has been programmed in by a human,
Yes.
or is that a generative thing that the robot is learning from whatever it's encountering in its environment?
In my world, we have to put in the puzzle pieces that the robot can to start to feel anxious, right? Because now I use the word never. I don't think it will ever be conscious, yeah? But I mean, because I'm not really sure how you define consciousness and what is required to achieve consciousness. But we have to put in the puzzle pieces so that the robot, by putting those puzzle pieces together, can feel anxious and then have an appropriate reaction. So the robot never will feel anxious, but for us, from the outside, it looks like he would be anxious because he behaves like that. I mean, that's the same for humans. I think this is sometimes forgotten. So we say, we as humans are much more intelligent and everything works different than machines, but we can't look into the humans also, right? We don't know, why do you feel anxious or happy right now? What we see is how you react, how you behave. And if I can simulate that behavior so that for an outside person, it looks like, oh, that's a happy robot or this is a sad robot, well, then it's a happy or a sad robot for me, without knowing what goes on the inside of the robot. Yeah? And a lot of this has to do with mimic and gestic. I'm not sure this is a proper word, but I mean, there are robots nowadays, they look very human-like. Yeah, so it's not this old tin can on wheels where you say, okay, that's a robot and we can't see anything of it. So I think if it starts to feel like, to look like the behavior of actual humans, I think then we will attribute also those emotional states with the robot the same way we do with humans. Of course, it has no central nervous system. It has not the biological brain. It's all electronic parts. But I mean, our brain is also only zeros and ones. So it's not like there is some magic happening in our brain that we say, okay, now you feel happy. So if you could trace all the chemical and physical properties of happy in our brain, we could have a mathematical model. And if we put then this model into a robot, it would do the same as we do. It's probably not possible, but who knows? You know? And we don't have to have the exact model. We just have to have a very good approximation. And that's, I think, the key, is that we don't have to create an exact copy of us. We just have to create a copy that looks, feels, and behaves like us. But it has different inner mechanisms.
So maybe the design doesn't have to be anthropomorphic. So I think even the reaction, the mimicry of emotion, triggers emotions in us.
Yes,
isn't it?
Of course.
So,
I mean, that's why they use this robot in this healthcare context, right? Because they are now able to pretend that the robot cares. Yeah. Yeah. And that makes the people felt cared, and that's the point, right? We would like that the people feel good, feel cared for, and if that then a robot can achieve that, yeah, then the robot can achieve that.
So, but you think that probably an AI or a robot, as the embodiment of AI, will probably not have agency. So consciousness, so conscious decisions, so agency is something different, but like a conscious decision won't be possible.
I don't think so. Yeah, so that's my feeling. So, but I have to say, it's similar to intelligence. So, what's consciousness? Consciousness. right? So probably there's a definition and there are some rules and something like that. But if you can formulate the rules when something is conscious, what is the constraint that something is being conscious, what is required. Well, if you know all of those things, then you probably can build it. I mean, there is no, I mean, you might need biological parts, right? I'm not saying that goes very wrong. But if you can describe it and you can build it, then you can build it. Yeah.
Heather, what do you think? Consciousness.
Well, I was thinking various things at the same time. I think there's the kind of anthropomorphic and the relational thing, I think, relates quite nicely. So as you were talking about the kind of understanding the happy robot or the response to the robot, I was thinking I can detect a happy slime mould. Mm-hmm. I know when a slime mould is happy or unhappy. In its environment, and it's the way its colour, its growth behaviour. So there's a kind of an understanding, a reading of those behaviours. And if I'm doing workshops with other people and inviting other people to create an environment for the slime mould to navigate, or take home a pet slime mould to care for afterwards. Then I'm trying to transmit that knowledge of that kind of tacit learning that I have gained from the organism as to kind of what a happy slime mould is, and I think that the language that we use, anthropomorphism, I think, is a really useful tool, and to be kind of aware of the problems of projecting onto other kind of subjective sensibilities, but I think the language is often similar in computer science of the kind of projection of agency or personality. But I think it's a useful. Well, we can't not be anthropomorphic, I think, because we are always relating to other things, and we can only do that kind of from a human perspective. So I've given up trying to avoid it and just kind of put my hands up to being anthropomorphic and recognise its limitations, that it is always a projection.
Yeah, because if you say the slime mold is happy, it's also your interpretation of its behavior. So it grows and it has vivid colors, so obviously it's happy.
And as far as I'm aware, that behaviour may be a slime mould in distress, or kind of desperately seeking another environment, or responding in a kind of a negative way from its perspective. So it is only an interpretation. And I guess when you're talking about understanding whether a robot is displaying kind of anxious or kind of positive response to a given situation, that's a kind of a code that has been programmed in, that is kind of understood and recognised by the humans looking at it. Mm-hmm. So I'm kind of speculating on whether, kind of in an AI world, whether there is a kind of a sense of the AI being anxious, if maybe it's just kind of information overload, or but again, that's a very speculative projection onto this other form of thinking.
Yeah, but if we speak of AI as this not clearly defined subject, machine, whatever, whether it's a robot, whether it's a network of computers or something like that, but an AI, and this is where I draw the line between. So we have to look through a mathematical lens and we have to look through a biological lens, and they are not always the same. An AI always wants to achieve a certain goal. Yeah, and this AI probably will never feel anxious because it tries to achieve this goal, and it tries to achieve this goal as best as possible. But for the AI, it actually doesn't really, so it has no feelings about achieving the goal, right? It's the only purpose, so it's in this sense very not intelligent, it just tries to fulfill this goal. with the systems today, we can it can try to fulfill very complex goals, and here the AI can, of course, say it's a logical machine, right? It's a very rational machine. So it says, okay, if I want to achieve this and I have to do that, then I have to do this. And these are these unintended consequences on our side. So for example, hey, the user wants to have a response to a question. I don't know it, so I just hallucinate something. The goal is achieved. I have given an answer. Yeah. But for the user is, the answer is not really good. Yeah. You have to get better. But the AI has achieved its goal. And it has no bad feeling about giving a wrong answer. It just has to give an answer. And if you experiment, for example, I mean, those chatbots are now a hot topic, or it's a common topic, but it's very easy to use, right? So you don't have to use a lot. But try to find a question where the AI says, hey, I don't know, or this is the wrong. They always give you an answer. Yeah? You have to go deeper into the system to generate an AI that says, I don't want to give you an answer, or oh, that's a stupid question, or something like that. Because this is not the goal. The goal is I'm responsive and I provide an answer. And then the second goal is it should be a good answer. Yeah, and it should be a correct answer. But these are probably not the first goal. The first goal is give an answer. The quality of the answer is not that important.
Well, and as you say, the quality of the answer is only interpreted by the human asking the questions. The AI doesn't know if it's a good answer.
Yes, in the training process, it gets a lot of answers, and it gets then a feedback, this is a good and this is a bad answer. So it learns over time what's a good and what's a bad answer.
But that's a predictive model.
Yes, but I mean, the same happens in humans, right? That's why we have those TV shows, kids that give funny answers, right? Because they can't really judge it's a good answer or it's a bad answer. And hey, that's the answer where my parents laugh, so it must be a good answer, but it's probably not a good answer. Yeah? And that's the same behavior. It's the feedback it gets from its environment, whether that's a good or a bad answer. Well, good or bad is very simple categories, but you know what I mean.
Have any AI answers made you laugh in the same way as a 5-year-old child's answer?
I don't have too much contact with 5-year-olds, to be honest. But no.
I'm thinking of those TV programs, the funny things kids say.
No. But I think this is because I think it's not just the words, right? It's how it is spoken, how it's the behavior at the moment, and how is the situation, the context that make you laugh. Yes.
So if the two of you, if you could create a transdisciplinary or interdisciplinary project, what would it be? Could you think of some kind of question or topic which would be interesting to address it from the two perspectives?
I will come at that answer in a kind of roundabout way and talk about transdisciplinary processes. So for me as an artist, I do work a lot with scientists and with other disciplinary specialisms outside of my own, and I find that a really enriching environment to be in. So in a transdisciplinary situation, you are always the expert and the novice. You're always kind of on the edge of your expertise. I mean, one could argue you are within your discipline, kind of always on the edge of your expertise. But I find the kind of the wrangling of that kind of in-between space between different ways of asking questions, different intentions of the outcomes. So for me, the first part of that process of answering your question would be to kind of extend this conversation and see, well, what are the touch points, what are the synergies, how are we using language, what are the things we're interested in, what questions are we asking, what methods do we use to ask those questions, what do we want the answers to be, and what other kind of questions might come. So I think it's quite difficult to answer on the spot, because I think there would be a negotiation of territory to kind of find, well, what could we bring to each other's practice as well, and what could we kind of extrapolate and take, and kind of what would the mashup be? I don't know, what do you think?
So I think the challenge posed by you today is about speaking about this intelligence, right? I think this is a good starting point, because I think intelligence can be viewed differently from different topics through different lenses. And then if you have this, let's say, machine intelligence and this biological intelligence, and I think there are, as you said, different touch points. There's probably very many different touch points, so you could make a big project about this by looking at all those single touch points. And at the spot, I couldn't say, okay, this is exactly the spot where we two should be working together or something like that. But I think this context of intelligence, and also not in the form of designing intelligence, but also what does this translate to? So what's the behavior that comes out? What maybe can we learn from it? What can we use it to adapt it to different situations? There could be, I think, interesting parts. So it wouldn't be about understanding intelligence. I don't think that is the point. It's more like, what can we learn from different types of intelligent behavior, and what is transferable between different disciplines? That could.
And
be
I think
something.
context, because we've sort of talked about the context and environment for that intelligence, and one of the things that I think defines intelligence in, for example, a slime mould, is the relationship and the dialogue it has with its environment. So it's chemically sensing its environment all the time, and that builds up environmental learning, habituated learning, and they can then pass that learning on to other slime moulds and share that information. And as a human in a climatically troubled world, I think the slime mould is an exemplar organism for thinking, how can we be better attuned to our environment so that we stop depleting our habitat and actually start nurturing our habitat, because we're pretty much the only species that is actively destroying our habitat. And so that kind of dialogical relationship between organism and environment, I think, is a really interesting aspect of how these kind of superorganisms work, because the complexity of the communication is very evident. And so with AI, I think because it's disembodied, unless you kind of you put it into a robot or some other kind of body, I'd be really interested in exploring how you can embody and create that sort of feedback loop between the artificially intelligent organism and its environment, of how that could be. So it's feedback loops in somehow between organism and environment.
Yes, and I think since it's not only the AI everybody uses and knows, but also those evolutionary algorithms or those methods, I think also one interesting point could be, as you said before, right? The slime mold grows 1 centimeter per hour or something like that. And with those algorithms, you might have a possibility to simulate this, to speed that up, to develop different scenarios, to use basically those ideas from the slime mold, and see what feedback is necessary, what changes if we change the feedback. And then we could, of course, also go to a bigger picture and say, okay, now we're not talking about the slime mold, but about human and the planet Earth or something like that. It's very far-fetched, but I think with those methods you have the chance to simulate processes that in the natural world would just take too long for us to observe.
So we can fast-track evolutionary possibilities.
Yes, with the high degree of uncertainty in the outcome, of course. Yeah.
that's where the fun is, in the high degree of uncertainty of the outcome, for me anyway.
Yeah, that would be a nice closing point and a starting point for projects, maybe by the students. Yeah, thank you for the conversation.
You're welcome. Thank you for the invitation.
Thanks.